My name is Chris Koliba, and I've been asked to give a talk on green infrastructure and climate change, and professor in community development and applied economics. And the work I'm going to share with you right now stems from an ongoing research project called RAC, Research on Adaptation to Climate Change. And it's a National Science Foundation sponsored program, and it's coordinated through Vermont EPSCoR. And we have a number of other affiliations that I'll actually touch on a little bit of the SEGS lab work in a bit. So what I'm looking at in this presentation are the confluence of climate change and the implications of climate change, particularly in Vermont, and its implications for stormwater management, things like smart growth, and what have you. And the audience that I was told would be a part of this are students and those that are entering the profession. And to that effect, I'll give you some background material on the basics relative to climate change, its implications for the state, and then lead us into a discussion about stormwater. So the first point of business is to point you to a tremendous reference that was spearheaded by our colleague Jillian Galford in the Rubenstein School of Natural Resources and the Gunn Institute. And about two years ago, or a year and a half ago, they published the Vermont Climate Assessment. And it's an online resource for you. For some reason, the website address isn't there, but it's www.vtclimate.org. So it's a great resource. And just to explain some basics about climate change, they have this tagline at the very beginning of the website. It says, climate is what you expect, weather is what you get, right? And so there's a distinction between climate change in terms of historical patterns relative to precipitation, relative to temperature, extreme weather events, and it's mostly precipitation and weather events that are most salient for green infrastructure. The coupling of climate with weather obviously gets you the sweet spot in terms of using climate change as a frame of reference for planning purposes. So we all know some of this data about climate change and what's anticipated. We have RCP scenarios that are being put forth by the IPCC. And they range from a best case scenario of a 2.6 scenario to a worst case scenario, which is 8.5. And these scenarios vary depending on how effective we are as a globe in mitigating and reducing our carbon emissions. And I'm sure we've been tracking that. Anyone with an environmental interest and focus would be apprised of this. But the bad news right now is that we're on track, and my colleague Asim Zia recently went to the conference in Paris in December, and consensus seems to be gelling around, in the very least, we're at the 6.0 scenario range without drastic cuts, and that we could very well easily get to 8.5 without doing anything. So, and as we look at then the temperature increases for places like Vermont, we're looking at anywhere between 7 and 8 to 9 degrees Fahrenheit increase in annual temperature by 2070 to 2099. Those are actually a little higher than what some of the RAC research forecasts are anticipating, but still, these are not inconsequential rises. And just to also underscore that climate change is already happening and unfolding, and one indicator is, let's say, the zones in terms of growing seasons. 1990, the more purplish is the colder zones, the more hardy zones. The greener is less hardy, the warmer zones, and you can already see that within a 15, 16 years time span, even just in Vermont, we've seen changes in the growing season. And this matches historical records kept by farmers, for example, in citizen science, where the first and last frosts and whatnot, and also historical weather data. So we're already seeing the effects of climate change in the region, and that this is a familiar way to think about where Vermont's climate would fit vis-a-vis the eastern seaboard in the lower versus higher emission scenarios. And we're looking at least this middle zone, so that by 2040, 2070, we're going to be having the climate of a southern Ohio or a northern Kentucky, and could be as extreme as a northern Georgia. I talked a bit about the research on adaptation to climate change, research on climate statistical downscaling. So our team, led by grad student Justin Gilbert, has published several papers. And I won't get into the details, the gory details of how you regionally downscale these climate models, because I'm not an expert in this. I just are taking this and sharing this information publicly. But the one method that is relatively settled and agreed upon is using statistics, historical statistics, to then project into the future where we will be going relative to things like temperature increase. And this is January to December, and the blue is the 2040 to 2060 range, and the red is 2070 to 2090 range. And basically the takeaway message here relative to temperature is that we're going to have warmer winters, and this is 0 degrees increase. This is 1 degree. This is a 3 degree, or no, this is a 0.5. This is a 1 degree. I think that's the scale. Celsius, and that we're going to get warmer winters and warmer across the board. But our winter weather will be actually more typical of what we've had in this El Nino year. Less snowfall, more rainfall, and what have you. And in these climate models, these regional climate models, projecting precipitation is less of a certainty, but I'll show you a little bit of data historically about the rise and increase in precipitation for the region as well. So the basic rule of thumb is that the wetter regions will get wetter and the drier regions will get drier, and certainly that is the case for our little neck of the woods here. That we're going to get wetter, and what that means is stronger burdens on our stormwater systems. Now, what are the implications of this? Well, we can be looking at, and we have done some work in workshop environments with stakeholders in our region to suss out the implications of climate change on all of these areas, and that Vermont climate assessment document I was speaking of does touch on many of these areas for Vermont. So again, it's a great resource. But they do have these intertwining implications for agriculture, river management, stormwater, forests, transport, wastewater development, energy, emergency management, and public health. And relative to the focus of this conference, we're looking at stormwater, but we can't divorce stormwater issues from river corridor management, from wastewater management, transportation, our roadway infrastructure, and our development patterns. And they're all intertwined. And the implications of climate change in the policy realm, we call it a wicked problem. It's a problem that is very, very difficult to solve. It's a complex problem. And it's coupled with these other factors. And so what are the consequences of climate change relative to a state like Vermont? Well, can anyone guess what that picture is from? Irene, right? So we have, within the last 4 years or so, an example of how an extreme weather event like a tropical storm can dump. This is in Wilmington, Vermont. And you know, from a stormwater management standpoint, this is obviously the extremes. There's no stormwater system worth its salt that can handle all of that water. And the consequences here obviously are tremendous erosions. And yet, despite that, you know, we survive and we adapt, perhaps find a little recreation in the muck and the mire. But so a major consequence of climate change for our region that we can expect are more of these kinds of events. And the consequences of these events are catastrophic. And here's just the pattern from Irene in terms of the monetary damage done by county. And it ranged into I think it was $500 million and upwards of damage. And it affected particularly the spine of the greens in this case, which then had this amplification effect as the water runs downhill. So stormwater management in our rural, more mountainous regions even poses that many more consequences, and we can see this happening within the context of Irene. Historically, then, as we look at the rain patterns, what we're finding is that in the spring melt-off season, which we're in the middle of right now, we're seeing increases in persistence of rain events. So think of it as rain-on-rain events, the increase of the number of days in a row where we are having precipitation. And so this is growing within a very critical time of our year, particularly when we think about the melt-off of snow and what have you. And so one of the amplifying problems that occurred during the year of 2011 was that we also had a double whammy. We had a spring that compromised our stormwater infrastructure and our roadway infrastructure through a series of these persistent storm events that then was coupled with an increase in intensity of storms in the latter part of the summer. So 2011 was the perfect example of how if you get both of these happening together, we're facing almost the perfect storm, so to speak. The increasing intensities during the late summer times, obviously then further compromises our stormwater infrastructure to a large degree. And we're also seeing these similar patterns, maybe not along the time frame of this monthly pattern, but across the world, particularly in our tropical zones. Right? For example, I spent some time this time last year in Sri Lanka, and these patterns were holding sway, different monsoon patterns, but the intensity of rain events, they were having fewer of them, but when they came, they were much stronger. And so the question becomes, what's our stormwater infrastructure responses to this? So one aspect of the research on adaptation and climate change work is to take a deeper look at this. And admittedly, most of our emphases so far in our project is really focused on agriculture and the implications for agriculture. But we're just starting to get into the stormwater and green infrastructure implications. So I'm going to share with you some data on a survey that we conducted with households across the state, stratified sample. The survey went out across the state and was administered by the Castleton Polling Institute. And we were able to survey and get 574 responses. I believe that's roughly a 30% response rate, which is in the ballpark for these kinds of instruments. If you've got questions about the instrument itself, I can share further details. But as we think about the distribution, and we still have to compare this to census tract data. So this is actually our first public display of some of this data. So we don't necessarily know how well this correlates with single family versus multiple family versus apartment and condo units per census tract data. But just to give you a sense of the sample, we've 85% are single family homes, which is really where we want to focus on to a certain extent, and that 90% of the respondents own their homes. So when we think about stormwater infrastructure or green infrastructure at the residential level, the renters have very little power in that regards. If you own, you obviously are the key decision maker. And that's really what the focus of this particular survey was what's the level of implementation of green infrastructure and what's your willingness to adopt a green infrastructure. And then in terms of the distribution of the size of the parcels of land, you get a fairly good distribution of what reflects the composition of Vermont's landscape. Less than an acre, 56%, a half an acre to an acre, 14%, a quarter of an acre to a half an acre, 13%, and so on. So we had a fairly decent distribution, greater than 1 acre, though a lot of the respondents had these larger parcels. And so if you've spent some time outside of Chittenden County, this is a fairly normal observation, right? You see the 10-acre plot, for example, was a norm for quite a long time. And there's a lot of effort and interest, obviously, in changing how can we change those patterns to a more concentrated development. So then we asked them questions like, is flooding a problem in your neighborhood? And 14% said yes, okay? In the past 3 years, have you experienced basement flooding, right? 17% said yes. So, you know, we have to align these two questions. They should be relatively close, okay? So there's a good amount. So what are the implications for individuals in terms of poor stormwater? Well, the cost of remediation of your basement, obviously, the cost to your public infrastructure in terms of your tax base, obviously, are huge. And then the question is stormwater runoff a problem in your neighborhood? Even though those may have not directly experienced the runoff, 21% said yes, it is. So we begin to paint a picture that there is a level of consciousness in the public's sense that there is this problem that needs to be mitigated. And then these are just, have you had your driveway washout? 32% said yes. Okay, so now we're getting a bit higher. Have you experienced runoff or erosion or washout of your lawns and gardens? 12%, right? So the idea is that there is a significant percentage of the population that has experienced this. And then the broader societal questions are, all right, so those are the individual consequences we can consider, the cost of remediation, the cost of damage, the raising of your insurance premiums. But there's obviously some larger societal implications, things like beach closures. So wrapping stormwater management to larger societal issues like the ecosystem services of our pristine jewel of Lake Champlain and the role of beach closures, whether it's due to phosphorus, nutrient loading, algae blooms, cyanobacteria outbreaks, or E. coli outbreaks when your stormwater and your storm systems, sewer systems run over. And then we get these large-scale infrastructure damages like this from Irene. And we get things that what we're focusing on with RAC are the algae bloom problem as sort of the indicator, performance indicator of how well we have a sustainable system writ large. And obviously, yes, we're looking at agriculture, but we're also looking at the implications for more developed residential and commercial. So I won't have the time to get into a set of Q&A, but my point being here is, my point being here is, making this personal. I could ask you a series of questions. We have a discussion about how many of us have swam in Lake Champlain? How many of us have thought twice about swimming in Lake Champlain? How many of us have shopped at box stores? How many of you have been caught in a flood? How many of you had your basement flood? Have you drank water from the Burlington tap? Have you ever voted in an election in Vermont? And how many of you have based your vote based on the candidate's position on water quality? My point being here is that we as individuals are not divorced from the consequences and causes of this problem. And that even though the mundane things about where we shop or what we do in our recreation time or where we eat or what kind of food we eat has these intricate connections. And this is a schemata of RAC and its relationships. So we've got natural scientists that are studying the terrestrial and aquatic ecosystems. And I could spend all day talking about what they've been finding. We've got a team that's looking at climate change modeling. And then our team, the social science team, is really looking at this interface between policies, social and economic behaviors, and land use, and how by using and employing social science methodologies and modeling techniques and things like gaming, we're trying to get at understanding what kinds of policy triggers will change and alter behaviors, which in turn will change how land use patterns are set, which in turn has an effect on our ecosystem. So we can begin to think about these problems in the context of a complex adaptive system. And one way that we can begin to think about this, and this is not a cartoon from our particular research, but I think it really does display the ways that one can think about the landscape relative to flood zones, parcels, land cover, elevation, and how they can be layered into a GIS frame to then start doing some anticipation of how different designs or alternative designs and policies and land uses will have an effect on things like water quality, volume of water, and what have you. And our Q1 team, our teams that are looking at the hydrological dynamics, are looking at things like the flow of nutrients off the landscape into the lake, and the role of oxygen, sort of the dynamics in the water column, the role of sediment and dissolved and non-dissolved phosphorus, and what have you, the role of weather events, wind, temperatures, and what have you. And what we're finding is that climate change is exacerbating the problems of algae blooms, for example, and is probably going to outpace anything that we can do from a policy response side, which is sort of a tragic conclusion. But there still is time to perhaps do some mitigation relative to that. So again, not really getting to the green infrastructure questions quite as much, but really our focus here is community-based adaptation strategies. Here the Vermont Department of Environmental Conservation looks at surface water management strategies across these domains, stormwater being one of them, but again, I want to emphasize that these are integrated with each other. So for example, if you remember that Irene came up the spine, the Otter Creek and Middlebury was not struck as hard as, let's say, Waterbury was, in part because there was relatively robust wetlands that were absorbing all of this. So we can't just think of stormwater implications divorced of some of these other ecosystem services. We also need to be thinking about the broader, not just implementation of specific green infrastructure strategies, but we need to be thinking about things like smart growth strategies. How can we redirect development patterns along smart growth principles? And how do we actually, my personal sort of crusade is, how can we actually put some teeth behind regional plans, for example, so that instead of having each town come up with their own plan, let's think of our regions, and let's actually think in terms of watershed governance. Like, let's have the Winooski watershed and do comprehensive planning around like that through that unit of analysis. Our team has done things like network analysis, and each one of these nodes represents an organization and institution. This is just to suggest that we can plot who's responsible and who's addressing the issues. When we ask citizens, both in terms of green infrastructure as well as water quality management writ large, when we say who's responsible, they generally either say the state or the feds. In the case of stormwater, people clearly see that towns are more responsible, and yet residents also have a burden to bear. So that as we think about responsibility and how we can use data and perception, public perception, to steer public policy, we can begin to say, that people say that the burden is on the towns, and that's shared across state and federal as well. So I'm not an expert on green infrastructure per se. My colleague Stephanie Hurley is, and I think she's either talked before or will be talking later. But she's part of our team. She's actually the lead on that survey that I just talked to you about. I won't get into the details about thinking about alternative design, but or get into a deep discussion about, the rain barrel and green roofs and permeable pavers and constructed wetlands and rain gardens, but these are all within the suite of solutions. And so we ask things, well, in the fertilizer application, and I was going to shout out to Chris, who's going to talk next about blue, among other things. And then, but as we think about self-reported adoption rate of green infrastructure, a lot of places are 40% are diverting rains, right? So we do this sort of informally. Rain gardens, 5%. Permeable pavers, 10%. Gravel or sand infiltration trenches, 21%. And then lesser so along these lines. We were kind of surprised, for example, in terms of sand infiltration trenches. So the fidelity of these self-reports is a little bit suspect. We're going to do some ground truthing. You got a question?
There's a question about the rain barrels. Have you looked at any of the possibility that these have to be large enough that they actually have an impact? But when you're capturing water out of the hydrologic cycle, I mean, isn't there a concern that you're reducing the ability of a downstream stream or lake to assimilate pollution because you've
taking the water out? I would probably, and we have some hydrologists in the room that can answer that better than I. I'm a social scientist. My sense is the amount of water diverted from something like a rain garden.
Right, but if that percentage was up, those percentages
even higher,
where we want them, 80-90%, we're not talking about an insignificant volume of water anymore, right?
But think about what happened when, before we had developed lands, we had trees and shrubs absorbing it. If we're just taking that water and reabsorbing it into the ground, you're mimicking what it was.
Right, but we also
had developed.
We also weren't producing above background levels of pollutants and nutrients and things like that too. So what I'm saying is that you're still contributing all those pollutants, but you don't have the volume to dilute it down as much. So you might be making problems like algal blooms worse.
Rain gardens aren't meant, rain barrels aren't meant to capture large quantities of water. They're designed to catch the first flush of water, which often has the highest levels of the pollutants.
Okay.
And so what happens is they fill and then divert. Okay. And so you're capturing that last little,
so as long as
that first bit that may have the highest levels of pollutants in it.
Rather than
exactly.
Okay.
Exactly. I think we've done some analyses looking at how many rain barrels you would have to distribute to actually make a big dent in the actual volume of water, and it's not great. As Chris is saying, we used to, nature used to divert much more of that water than we do now. That's the problem of the urban syndrome. We're getting much more water more quickly to the streams, and that's what's causing all of it.
So I'll just wrap up to say that we're interested from a policy perspectives of carrots and sticks. So I look at policy tools in terms of how to incentivize behaviors, and we could have an extended conversations about what we think are going to influence people's decision to adopt green infrastructure, from their direct experience with floods, to their exposure to green design ideas, to broader concerns about climate change, peer adoption rates, ease of access and know-how, the affordability of the solutions. When we ask things like, what's your willingness to pay for annual adoption of stormwater? This is just one response to a series of them, that there is some level of willingness to pay, to basically pay for green infrastructure. We are doing some work relative to gaming, so anyone who's interested in playing some of our games relative to these kinds of questions, we have the SEGS Lab. Here's our website. We are looking to recruit students and others to play. You can earn $20, $30 per play. And we're also having a talk by someone that's coupling gaming with governance, talking about Minecraft tomorrow. So I just wanted to give a shout out there. And then lastly, I thank you. And just to say, this is a shot from the windshield in Havana, Cuba. We were there recently, and they also have major stormwater runoff issues. So thank you. Apologize for
Chris, is there any indication from the RAC report about how well prepared our current
infrastructure is for climate change?
Yeah.
And if so, do you have any further information about how well green infrastructure could fit in
Right.
the void?
That is going to be a major focus for the next 5 years. So we've just gotten a sort of a soft announcement that we've gotten the BRE, it's called Basin Resilience to Extreme Events. So it's another 5 years. It's RAC Part 2. And that focus will be on extreme events. And this first 5 years was really just wrapping our minds around, mostly around the ag sector. So the next phase is going to be focused on just that very set of questions. And the neat thing in the simulated environment, which I didn't even touch on, that you could begin to say, all right, how are we going to simulate green infrastructure out of adoption? And if we get, let's say, a maximum, what percentage of adoption would yield the right balance of return on investments, we can at least provide some feedback to policymakers to consider this. So, yeah.
So, just I'm Dan from Chittenden Regional Planning. The university is part of a flow restoration plan for Centennial Brook, and that flow plan, which is a partnership with UVM, Burlington, VTrans, and South Burlington, and the consultant went through that and identified a variety of retrofit practices. The hard thing is in the built environment. The primary candidates are some of the large ponds that UVM has, unless you start ripping up some parking lots, which would be, if the university started doing more policy of shuttling and not allowing as many cars on campus, and the parking, the harder it is you make for people to park here, the better it is in the long run.
Right. Well, then those are the trade-offs, right? So on those questions.
Oftentimes, but that particular report for Centennial, which if you talk to Bill Netty or Lonnie, she's got the report.
That's great.
Planning, and Bill Netty's from Krebs, who helps with the MS4 permit compliance.
Good.
So.
And are you cautiously optimistic that UVM is getting its mind around sort of walking the walk in that regards?
I think so. The hard thing is the monetary costs, because I think the fix alone for Centennial Brook over the next 20 years, it's upwards of 30 or 40 million.
Wow.
That's just one of the 9 streams in the county that's impaired.
Yeah.
So.
I was talking with Kerry Dolan, who's our at the state level is really charged with thinking about water quality, and this is also part of a group that Breck and I are part of. But really, we're especially with things like Flint, our water infrastructure. We're talking about probably an era of looking at our water infrastructure much like we do our transportation infrastructure at that level of investment. And I think that's the paradigm shift that climate change, whether we like it or not, is going to pull us in those directions. So at least that's the conclusion I'm drawing at this stage. So good.
Dan?
Yeah.
Do you think that UVM is, the situation that UVM is representative or not of the rest of Chittenden County, based on, is that the sort of magnitude of problem we face?
Well, at least I know for Burlington and South Burlington, the tab is quite high. Some of the other streams are, like Colchester, Sunderland Brook there. They've had quite a few studies on that there, and that's, looking good to meeting their flow targets. But it's interesting because one of it is this thing of, it's a flow plan, because sediment is for flow. One's a surrogate for the other, I always forget which is the, but that plan is just flow.
Flow, yeah.
It doesn't deal with phosphorus.
No.
So as we start to implement the TMDL, how do you get credit? So and then you get this weird thing where you could meet the flow targets,
But not the
then
sediment.
20 years from now, we count all the bugs in the stream, and it's still the same.
Yeah.
So is that bad?
And then you get climate change on top of it, where you're overwhelming your stormwater infrastructure with these larger, intense events.